Hi guys, welcome to Science at Home with Miss Bowman. The first experiment we're going to do is called tie-dye milk. You need some milk or half and half. Something with a higher fat content will work better, so I'd recommend whole milk if you do have it. We're going to take our milk and we're going to just put it into the bottom of our container. The next thing you'll need is some food coloring. I'm going to put several drops towards the middle. All right, you're going to take a Q-tip and you're going to put it into some dish soap. And then you are just going to place the dish soap into the middle of your coloring drops. So here's the science behind what's actually happening here with the tie-dye milk. What you are doing is you are actually reducing the surface tension of the milk or half and half, and what happens is the soap, as we know, is a good degreaser. So what it's doing is actually breaking down the fat molecules that are in the milk. And so what happens is as the soap is being placed into the milk, you are reducing the surface tension right in this area, and it causes the milk that is around the soap to have higher surface tension area, which actually wants to flow the milk towards the higher surface tension area. So it pushes it away from the soap, causing it to swirl your colors. So there's tie-dye milk. The next one we're going to do is called egg in a bottle. The things that you will need are a hard-boiled egg, a bottle, a lighter, and then something to ignite. You can use a candle, you can use a match, a piece of paper. I'm going to use a small piece of fire starter. So the first thing I'm going to do is ignite my object. And then I'm going to put it into my bottle. And then going to put my egg on top. As you can see, it cannot fit. All right, and it went into the bottle. So here is the science behind this and why it happened. When we started, the air pressure inside the bottle was actually the same as outside the bottle. Whenever I placed in the burning object into the bottle, the air pressure began to heat up and expand, right? We talked about how whenever you heat up molecules, they begin to move faster and they begin to expand. And then after I put the egg on top, the fire went out and the fire starter stopped burning. This caused the air inside of the bottle to start to cool down, and it began to contract or get closer together. As the air contracted, the air pressure in the bottle was actually less. So now that the air pressure was higher outside of the egg, it forced the egg into the bottle where the air pressure was less. Hope you guys enjoyed. Okay, the next one we're gonna do is an at-home lava lamp. So what you need for this is vegetable oil or some type of oil, some water, food coloring, and some fizzy tablets, also better known as Alka-Seltzer. So the first thing that you're gonna do is you're gonna fill up your jar. I'm gonna use a mason jar here. You can really use whatever container you want. I'm gonna fill it up about 3/4 of the way. And then I'm going to fill up the rest with water. I'm going to add some food coloring. And then I'm going to take my Alka-Seltzer. And I'm going to add my tablets in. And as you can see, you have made a lava lamp. Okay, so here's the science behind the lava lamp that we just created. So when you pour the water into the bottle on top of the oil, we know that the water sinks to the bottom and the oil stays on the top. That's because we learned with density, right? The oil is less dense than the water, so that's why it stays on the top. When you add in the fizzy tablets, what happens is you start creating that carbon dioxide gas, and the bubbles actually attach themselves to the colored water and cause them to float to the surface. However, since they are more dense, as the fizziness and the carbon dioxide go away, the water is going to sink back to the bottom and the oil is going to want to stay on top. So that's why they begin to re-separate. Hope you enjoyed it. Okay, so the next experiment we're going to do is the floating paperclip. As you can see, if you put the paperclip into the water, it does not float. So what you need for this is 2 paper clips. You're going to take your first paper clip and bend it into an L position. You're then going to take your second paper clip and balance it on top, and then very carefully you're going to lower it onto the water. And as you can see, it is now floating. I can tell you the science behind this. So what's actually happening here is it's not really floating, it's kind of tricking it into floating. And what you have is surface tension. So what surface tension is how close together molecules are. And so the water molecules here are close enough together that they're kind of sticky to the point where it's holding up your paperclip. Because normally, as you can see, a paperclip will sink. There you go. Hi guys, for our last experiment that we're going to do, we are going to do elephant toothpaste. This one's pretty fun. The things you will need are hydrogen peroxide, dish soap, some yeast, some warm water, and food coloring if you want it to be colored. The first thing I'm going to do is I'm going to measure out half a cup of hydrogen peroxide. Put it into my flask here. You can use whatever container you have at home. You can use a pop bottle, you can use a Tupperware. You kind of want it to have a skinnier top though, so that it does have that leverage to shoot out. All right, the next thing that I'm going to do is I'm going to take my packet of yeast. You're going to take your packet of yeast and you're going to put it into a container. Okay, and the next thing you're going to do is you're going to take 3 tablespoons of warm water and mix it with your yeast. You want to stir that up to where you kind of have a mixture of the warm water and yeast. Then you want to take your dish soap and you want to add 1 tablespoon of dish soap. Okay. The last thing I'm going to do is add my food coloring. Depending on how colored you want, depends on how many you're going to put in there. I'm going to do anywhere from 8 to 10 drops. I'm going to swirl that around where it gets nice and colored. The last thing that I'm going to do here is I'm going to add my yeast mixture to my flask and we'll see what happens.
What's happening here is the yeast acts as a catalyst, which means it speeds up a chemical reaction. The chemical reaction is the hydrogen peroxide breaking into oxygen bubbles and water. The oxygen bubbles get trapped in the soap, which causes it to foam. The bottle is actually hot because it's an exothermic reaction.